Welcome to today's video. So now we are going to solve this question. Binary subarrays with sum. Given a binary array nums and integer goal, return the number of non-empty subarrays with some goal. A subarray is a contiguous part of an array. We all know this. So what are you given with? You are given with an array which is having binary 0 or 1, and you have to return the number of non-empty subarrays with a sum equal to goal. Suppose we will take one example here. Wait a minute. Okay, so this is an array 1 1 0 0 and 1 1 0. So what will be the brute force approach? We have to create goal equals to 2. Let's take a sum variable with 0 and now apply brute force approach. What is the brute force approach? Creating all subarrays using 2 for loops. How? First this subarray. What is the sum? 1. Count is still 0. Now what for this subarray, sum is 2. Now it is equals to goal, so we will increase the count. Now this subarray, still 2, count increases. For this subarray, still 2, count increases. Now for this, sum becomes 3, so we will break the loop and count is 3 only. Now we will start from here. This sum is, and we will re-initialize the sum to 0. Now sum is 1. Okay, still 1, still 1. Now 2, so count increases to 4. So count increases to 4. Now for this, sum becomes greater than 3. Sum becomes 3. So we'll break the loop. Now we'll start from here. Hope you will understand the brute force. Now we'll write its code. Very simple. Int count equals to 0 and we'll use 2 for loops. Int equals to 0, I less than nums dot size I plus plus for int j equals to I, j less than nums dot size j plus plus. Now before this loop we have to initialize sum also for each subarray. Suppose this is the sum. Now we will increase the sum by nums of j. If sum equals to goal, then we have to increase the count. Else, when sum is greater than actually, not else. Else if you can write sum is greater than goal, then what do you have to do? You can break the loop. Also you can return this, you can return the answer count. Let's run this. What I have written. You will submit it and you will see time limit exceeded. See, time limit exceeded, 60 days passed. Now we will move to another method which is better solution of this. So we will do the dry run again. Let's do the array. We'll take the array again. So array is 1 1 0 0 1 1 0. We will use a method called prefix sum. We will initialize with 0, and we will take a map also. Which will initially have prefix sum 0 with count 1. Okay. Now, how this method works? Suppose this is a prefix sum you have calculated like x. Now our goal is, suppose here it is 2, let's suppose it is k. So if our goal is k will lie anywhere. K is a subarray, so it can lie anywhere in the middle or here. So if we somehow find x minus k, because we have stored this in map, we have stored all the prefix in the map. If we found x minus k prefix sum in our map, so this means k also exists, and the number of times x minus k exists, the number of times k exists. Suppose you will do the drawing and then you will understand how. Suppose you start from here, prefix sum becomes 1, you store 1 comma 1, then you move here, prefix sum becomes 2. So before 2 you have to check also 1 minus 2, because this 1 is x, this is k, x minus k equals to minus 1, which is not in the map. So move ahead, you came to 1, then prefix sum becomes 2, you put in this in the map, 2 comma 1, this is the count of prefix, how many times it is coming. Now check 2 minus 2 equals to 0. Now see, 0 is in the map, we found the 0 in the map. This means what? This the prefix sum is 2, and you found the x minus k 0, which is nothing. So automatically k is existing in somewhere in the middle. Here it is the whole, but this is how it will work. K equals 2 and goal is also 2. Some k equals to 2 exist. So this means you will increase the count to, let's make a count variable, count to, initially it was 0, now it becomes 1. Move ahead, again prefix sum is 2, increase the count of 2, and now you will again check 0 coming, you will increase the count 1 plus 1. Now again move, again 2 prefix sum, it changes to, count changes to 3, and you find again 0 here, so you will put 1. Now again prefix sum becomes 3, you put inside the map. Now you check 3 minus 2 equals to 1. 1 is existing with count 1, so we will increase the count. Now 4, you will put 4, you will put 4, and also you will check 4 minus 2 equals 2, and also you get this one. So 2 is 3 times, see, so we'll increase 3. That's why count is being used, because I will show you how this 2 occurring 3 times. We have taken the subarray this. Now see, there are 3 subarrays with 2 sum. How? One is this, one is this actually, and one is this, and one is this. That's how it is working. It is counting automatically. Now let's see here, again 4 increases to 2, and 4 minus 2 equals 2. Again we will add 3, so total count is 10. This is the answer. Hope you understand the solution. Now let's code it. So I will reset it. We'll initialize the prefix sum with 0, count with 0, map int comma int, we will make a we will put a we will put 0 comma 1 inside map. Now we'll initialize the for loop. So now we'll calculate the prefix sum. Prefix sum is nums of plus equals to nums of I. Now we will check inside the map. What will check? X minus k. We have to check x minus inside the map, x minus k. So we'll make a variable which is x minus k equals to prefix sum minus goal. Now if we find inside it then we will increase the count with map of x minus k. Simple. Else, and also we have to update inside the map also, prefix sum plus plus. Now it's okay, I think, and we have to return the answer, return the count. Let's run it. What's the error? Output is 20 by let me check. Yes, I found the bug. We will update the map value with prefix sum afterwards, after doing all the operations. Now it's working, it will be submitted. See, now what we have to do now, time complexity is n log n. Why? Because we are using ordered map. N log n, and space also log n. Space is big of n of map. This is the time complexity and space complexity, and because of for loop and find and operation n log n. So yes, now let's move to the optimal solution of this. Optimal solution. Let's move on to the optimal solution. So we are studying two pointer. So let's start with two pointer approach and see what is the problem in it. Suppose these are the 2 pointers, and we'll make a sum equals to 0, and we'll make a count equals to 0. Suppose and goal is 2. First of all, sum is 1, count is nothing. Sum is 2, count increases because goal is matched with sum. Still count increases, still count increases. Now here you saw sum equals to 3, which is greater than goal, so you will move the left pointer. Okay, sum is again 2, you will increase the count. Now what you will increase, left pointer or right pointer? Because by increasing any pointer you are getting the sum. By increasing suppose you are increasing right pointer first, you get sum again equals to 3. Now you will move left pointer. Now while moving left pointer, you do some 2, count equals to 4. But now what you will move, right pointer or left pointer? Because doing both, you are getting the subarrays. See, this is also having some 2, this is also having some 2, this is a dilemma. So let's solve this problem by doing something else. Suppose you found number of subarrays with sum less than equal to goal. Suppose this is a set. This is a set of less than equal to goal, and now you calculate a sum less than equal to goal minus 1. This would be a subset. Suppose this is 2 and this is goal minus 1 is equals to 1. See, so what is this? What will be the value of this? 2 minus 1, sorry, these are the elements which are less than equal to 2, total elements. These are elements which is less than equal to 1. So if I would subtract this, we will left with only the element which is equal to 2, goal equal to 2. You see this maths? These are the sets. Now let's do the dry run with this concept. How will use 2 pointer? 1 1 0 0 1 1 0. Now let's make R and left and right pointer. Use sum equals to 0 and also count equals to 0. We have goal equals to 2. Let's make it. Now we will increase the count because sum is less than equal to goal. Increase the count. Now R. How many subarrays? See how many subarrays? 2 subarrays can be formed with, because sum equals to 2 which is less than equal to goal. So how many subarrays can be formed? We will increase the count. How much? See, one subarray is this, one subarray is with this, and one was already there because of one subarray. So now see the magic. It is 2. Move the right pointer again. 1 2 3. So you are seeing this is actually length. How you calculate length? R minus 1 plus 1. This you have to add this when you are moving right pointer when it is less than equal to goal. Again move R. Again you will add 3. Now you will add 4. Length is 4. Now again R. Sum equals to 3 which is greater than goal. Now what you will do? You will move left pointer. When you will move left pointer, see goal becomes, sum becomes 2, again less than equal to goal, again less than equal to goal. Now you will again add the count R minus L which is 4. Now again move right R pointer. Now what you will get? Sum equals to 3. So move left pointer. Again sum equals to 2. Counting this by 4. Again increase right pointer. Now sum is 2 only. So add 5. 1 2 3 4 5. This. Now again when moved right pointer it ends, while it ends. So how much? Approx 29 plus 4, 13 plus 4, 17, 3, 20, 23. Now these are with goal less than equal to goal, but we should also calculate less than equal to goal minus 1. We will just pass this into the function, same function which we will make, and we will get the answer. How? Goal minus 1. You will pass it in the function. So we will get the answer. Let's code it. I will reset it. Int sum equals to 0 int I, int left equals 0 comma r equals to 0, int count equals to 0, while r is less than nums dot size. While r is less than nums dot size, what you will do now? Just increase the sum by nums dot r. Now if sum becomes greater than goal, what you will do? Also copy this function. Once copy this function, we will make a function of this. Let's call it f. And we will return function with nums comma goal minus function nums comma goal minus 1. This would be the answer. While sum is greater than equal to goal, what we have to do? We have to increase the decrease the sum first. Let's decrease the sum by nums L and also increase the left pointer. When it becomes equal, we have to increase the count by how much? R minus L plus 1, and we have to increase the R pointer. We can put in a condition also. If sum is less than equal to goal, then we have to do this. Also return this answer. Let's run this question. Sum is nums minus, wait a minute, what is int, okay, wait, because we are passing goal minus 1. Suppose goal is 0, so and we are passing goal minus 1. So if goal minus 1 by mistakenly, suppose goal minus 1 equals to 0, if goal is less than 0, it is equals to, because suppose goal is 0, 0 minus 1 is minus 1, then we have to return answer 0. We have to return answer 0. Let's run this question again. Now it is accepted. %. Nice. We will meet in the next video. Till then, goodbye.